Assalamu alaikum, everyone. Thank you, Dr. Ibrahim, for the introduction. And I would like to thank the organizers for the invitation. My talk today for the next 20 minutes would be about the MPNs, the Omani experience. In this talk, it would have two short parts. One is to highlight the familial aspects of MPN in Oman, and I'm sure in the region. And I'm just propose very briefly how we can research this, and then explain the different MPN phenotypes despite the same driver mutation, the JAK2. It's a study that we've tried to explain these different phenotypes. So I would start with the presentation of one family. I had a patient who's 72 years old male who presented with pancytopenia. He had massive splenomegaly, and his bone marrow biopsy showed advanced collagen fibrosis. He harbored JAK2 V617F mutation, and his final diagnosis was MPN. The subclass was primary myelofibrosis. Unfortunately, he had significant pancytopenia. We could not start him on ruxolitinib. That was maybe a few years ago. And he underwent splenectomy. He had a complication of major bleeding after splenectomy, and unfortunately died with sepsis a few days after splenectomy. Now, a few years after that, I got a referral from a hepatologist. And that person, that patient turned to be the son of my old patient. This is a 36 years old, referred from a hepatologist with chronic liver disease and portal hypertension. He had large spleen, and he was saying his spleen is out of proportion of what would I expect for a portal hypertension. Despite having normal counts, he just told him that my father had this, and then he referred him to us. What we did, actually, we started with the molecular testing, and he was JAK2 positive, the same mutation that his father had. And then went and did a bone marrow biopsy, which revealed fibrosis grade 2+. So his diagnosis was primary myelofibrosis. Now, this presentation is the well-documented presentation for the familial MPNs in literature. If you look at the literature, and you took one of the large study there, they presented a number of families, including those 4 families. And as you can see, that the phenotype that they have, let's say in the earlier generation, PV, is the same phenotype that later generation gets, PV. In family 1, in family 2, and the example here is ET, and in family 3, the example is myelofibrosis. In family 4, PV, and the later generation showed myelofibrosis, but this could be post-PV myelofibrosis, and it is difficult to ascertain. Now, this is the classical description of MPN, what our case had. I'm sure you've seen in the region, in Saudi and in the region, similar cases. However, we do also see a different phenotype than what is reported in literature. So this is another family, a 48 years old male with anemia. He had massive splenomegaly, and his bone marrow biopsy showed grade 3 plus fibrosis. He had JAK2 positive, and his final diagnosis was primary myelofibrosis. After actually 2 years of his follow-up, he told me that I have an older brother who has been treated somewhere else, and he came recently to the country. So I asked him to bring his brother, and his brother was 52. Again, exactly the same presentation: anemia, massive splenomegaly. He had more advanced fibrosis, almost the same fibrosis, actually 3+. However, the interesting part that he did not have JAK2 mutation; he had CARL mutation. And his final diagnosis was, again, primary myelofibrosis. So this is a different phenotype where the phenotype is the same. However, the mutation, the driver mutation is different. We tested both of them. We tested this one for Carl and Jack too, and we tested that his sibling as well for Carl and Jack too. So they probably have something before Jack or Carl that predisposes one to Jack and the other one to Carl. So that's another difference that is not really described in literature that we see here. The other phenotype that we see here is not well described in literature, is illustrated by this family 3. This is a 38-year-old female with leukocytosis, classical presentation of CML, BCR-able. We see her, and after a few visits, she brings her mother, and she told me that her mother has been treated multiple times with antibiotics because her white count is high. So we tested her mother. She had mild leukocytosis, and she was negative for all the classical mutations that we could test, the BCR-able, JAK2, CAL, and MPL. We went and did a bone marrow, which showed pre-fibrotic stage of primary myelofibrosis. So this CML with a mother having unclassified or maybe pre-fibrotic myelofibrosis. So this is again not well described in literature. So that illustrates that we do need to investigate this area. One way to investigate it is to follow the steps of genetic epidemiology. And here I would list the steps in genetic epidemiology and maybe highlight some of the areas that we could research. The first step in the genetic epidemiology is description of disease characteristics, which is, if you look at the literature, it is full, like worldwide and also from our region, and I'm sure from different countries. So this is descriptive epidemiology. The second part is demonstration of the familial clustering. And the way you do that, you take all your MPNs and you see how many familial clustering, cases clustering in different families. This is also being done in literature. And if you look at the MPN, it ranges between maybe 7 to 8% of patients with MPN would have a strong family history of an MPN. So this is, again, described. What is also described is the relative risk. So a relative risk here is an estimate of how strong is the gene component, the driver of the gene driver. So if you have high relative risk, that means there is probably like a driver, really a strong driver. If you have a strong, if you have a low or a small relative risk, then you have maybe a mild driver here. And if you look at the MPNs, specifically the non-CML, the PV, ET, and myelofibrosis, the relative risk is in the range of 7 and 8. That is that the risk of having an MPN, if you have a sibling with MPN, compared to the population risk is 8 times, which suggests that there is a strong, probably a strong driver there. If you look at the CML, the difference is significant. The relative risk there is about 2, while there is about, while in MPN, that is non-CML, is about 8. So this is probably is needed that we should do it here because we may have a different genetic predisposition with a stronger relative risk. The second question, the second step, or the next step in genetic epidemiology is to ask whether this familial clustering is because of the environment. Families most of the time live together, or no, it is a genetic driver. Here, to illustrate this, you will need specific designs in that regard. Twin, adoption, half-sibling, migrant studies that would tell you whether that relative risk is because of a genetic component or an environmental component. This is, again, definitely not done in our region, but may be done to some extent internationally. The next is mode of inheritance. And you illustrate this by doing a segregation analysis. You just draw the family pedigrees, and through this you illustrate, you demonstrate whether this is a dominant or a recessive X-linked or other or a polygenic. The next step, after you demonstrated that there is a genetic component, you need to identify the region, identify the gene. And you do that by linkage analysis. Again, linkage analysis here is not well studied in the MPN literature. The mutations that have been described with the susceptibility loci research goes again to the JAK2, CAL, maybe retinoblastomas gene. But this is again an area that we could also study. The last part is the disease susceptibility markers. Okay, we know the gene, but is there, where is it in the gene? What is the allele? What is the marker? And for this, you need to do association studies. And classically, association studies states, specifically if you went with whole genome, like a genomic approach, then you will need a very large sample size. And this is definitely, it will need a collaboration from that region. So, this is the first part, the familial component, the familial aspects of MPNs in Oman, and I'm sure also in the region. The second part of my presentation today is an attempt, a study, to try to explain why a single driver mutation, JAK2, gives you different phenotypes, PV, ET, and myelofibrosis, or even unclassified. So if you look at the MPN and you do a bone marrow, you would see either a panmyelosis, which suggests the PV, megakaryocyte proliferation, which suggests essential thrombocythemia, or advanced fibrosis or megakaryocyte proliferation with granulocyte proliferation, which suggests myelofibrosis, either fibrotic MF or prefibrotic MF. And you look at the driver mutation, predominantly JAK2 in PV, more than half in ET, and more than half in MF. So again, a single driver mutation, JAK2, gives you different phenotype. What is the reason? So here, maybe we hypothesize that it may be the epigenetics that drives the phenotype. So you have a JAK2, but you have different epigenetics, mutations, or different phosphorylation that can explain the different phenotypes. So what we did, we did a study that included patients with JAK2 positive MPN, only JAK2 positive MPN, only for adults. And between the two major hospitals in Oman. So we captured most of the MPN patients diagnosed in Oman. The study was retrospective, but the molecular testing was done on diagnostic samples that we kept for those patients. Now, this is overall a small study, and most of the analyses are more of exploratory analysis rather than hypothesis, more of hypothesis generation than hypothesis testing. So we went into these genes, the modifiers of the epigenetics, the AXL1 and 2, DNMT3A, EZH2, IDH2, TET1, and TET2. Later, our molecular biologists added other mutations, but we sequenced the entire coding region of those genes. Unsupervised cluster analysis was done. We used ion torrent next generation sequencing for sequencing. And then we've identified the variants, and we've tried to classify the variants either based on the ClinVar database, based on the clinical information, or if we did not find the clinical information there, we went with other tools of the SIFT and Polyphen2 tools that could use computer prediction, in silico prediction, of whether this variant is pathogenic or not. We had a total of 61 patients. Almost half of the patients were PV, The other half were 80 and myelofibrosis. The median age of presentation was 62 years. As expected, more males. Half of the patient had splenomegaly, and maybe 1/4 of the patient had thrombosis at presentation. Now, this is the classical findings in CBC. It is also important to mention that the median erythropoietin level was 1.2 with a range of 1 to 4.8. So fairly suppressed erythropoietin. The first part is the heat map. So with this heat map, these are the variants that we found before the classification, whether they're pathogenic or not. We kind of included all the variants. And here are the number of samples. And as you can see in the heat map, there is no specific pattern from that heat map that would cluster the samples or the variants. Maybe with the variants on the rightmost, they are different for almost all of the samples. So there is no specific pattern in our heat map that could help us correlate it with the phenotype. Then the clustering. Here with the clustering, we see two major clusters and two subcluster in one of the major clusters. Again, although the clustering was done and the system was able to give us a dendrogram, but when you try to superimpose the subtype, the MPN phenotype, it does not really correlate well. So now using unclassified variants and unsupervised clustering methodology, we could not use the epigenetics information into the explanation of the phenotypes in MPNs. So the next step is maybe we said the frequencies, the load of the variants may be important. And on a median, 13 variants were found per patient. That ranged from 11 to 14. So relatively large number of variants. And as you can see, most of the variants were found in the classical genes that have been associated in the clonal hematopoiesis in the elderly. So ASXL1, ASXL2, and TET1 and TET2. So most of the variants were found in these four genes. And then we tested whether that load could explain the different phenotypes.
Dr. Murtadha, you have 2 minutes more only. 2 minutes.
Okay. It did not explain. The only difference is that those with a higher load showed significantly suppressed erythropoietin of 0.9 versus 7.6. Now, in terms of the load, it did not. And this is what we said, maybe let's only select the variants at the pathogenic variants. And we had almost 8 pathogenic variants that we could classify from either ClinVar or the in silico prediction, and with the MAF, with the mean allele frequency of more than 5%. Now, this is a little bit complicated and busy. Here is the genes. Here are the genes that we tested, and the different colors of the bars are the different phenotypes. The size of the bar illustrates the p-value. So it is a similar concept to Manhattan plot. And here what you want shorter bars, hopefully less than 0.05, that would try to explain it would be statistically significant. And as you can see here, that there are few findings in TET2, mostly actually in TET2, that would correlate it with the white cell count, LDH, and maybe erythropoietin. But it still did not correlate with the phenotypes. So the conclusion of this study that mutation load is not associated with MPN subtypes, though it did correlate with the EPO level. Mutation profile is not associated with the MPN subtypes. Incorporation of the clinical information did facilitate some of the prioritization of the variants from the DNA sequencing experiments. we did find few variants that did correlate with some of the clinical information, though there is an issue of multiple testing, specifically in this small study. The other major limitation is the study was retrospective. Now with that, I would like to thank whoever contributed to the different aspect of this study. And I would like to thank you for listening and the organization for the invitation. Thank you very much.